Hi everyone. So in this lecture, we'll start our third module, which is antenna feeds and losses. So antenna feeds and losses, basically, in order to energize your antenna, how you will send the energy to your patch so that it can radiate. Some means is needed in order to propagate. So in order to send the signal, that is why we can use the antenna feeds. These feeds are also some four, three to four types are there. For line feed, coaxial feed, aperture feed, and proximity feed. So these all we will discuss one by one. Before that, I would like to give a, I would like to briefly explain what are the losses which can be considered, which can be a factor for your degrading performance. And in some cases, these types of losses we can't even ignore, we can't even avoid, we can't even neglect it, and further we cannot even minimize it. Okay, so further, I will start with the radiation losses. As you might know that in last module, in the last session also, we saw the quality factor due to the radiation losses, conductor losses, or you can say the conduction losses, and dielectric losses, and surface wave losses. Okay, so radiation losses, conduction losses, dielectric losses, and surface wave losses. So in this case also, radiation losses, the formula for the radiation efficiency we all know, that is eta is equals to power radiated, which is outward means emitted, and power input at the port, definitely. So we all know P is equals to VI and P is equals to I square R. I square is nothing but the dissipation losses only. So input power, which is given as P in is equals to I square in, means multiplied by R. Now R here is load resistance plus radiation resistance also. And similarly, P in will be radiated power and load power, it will be. Okay, so radiation resistance, anyway, it is R in is equals to RR plus RL. Okay, so these kind of formulas are there, which by which you can think. So radiated power and at load power, it will be same only. And in case if I will divide this eta, radiated power and input power, with each and every one, so I square in will cancel out each other, and we will get r square rr 1 plus rr by rl, which is radiation resistance divided by rl, that is load resistance. So total power from source, real power, radiation resistance, and power losses. So because of the radiation losses, also because of the ohmic resistance, as you can see in this case also, reactive power is there, real power will be there. Okay, radiation resistance, whatever that it is emitting, but it is not properly in a fine way, it is not traveling. So that time also this radiation efficiency will be there. So radiation efficiency is nothing but how much it is given, and whatever we are losing, that is nothing but the losses only. Radiation resistance, I already have mentioned that it is neglected in the real scenarios sometimes. Okay, so now